In this first video, we'll look at the definition of an absolute value. We'll look at it in two ways. We'll look at it in what you've typically probably heard of as an absolute value, which is that the absolute value of a number is its positive distance from zero on a number line. And then we'll look at a mathematical definition of the absolute value and what the graph of an absolute value function would look like. So let's start with what you probably have learned in the past, which is that an absolute value is the distance a number is from zero on a number line. So we were to look at a number line here. Remember, 0 would be in the center. Going to the right, we'd have positive numbers. So 2, 4, 6. And going to the left, negative numbers, negative 2, negative 4. And if we were looking at the absolute value of, say, 3, that would be, here's 3 right here. How far away is 3 from 0? Well, it's 3 steps away, so would it be a distance of 3? So the absolute value of 3 is positive 3. If we were to look at negative 3 over here, negative 3 is also 3 steps away. So the absolute value of negative 3 would be equal to positive 3 as well. So sometimes people just think about the absolute value undoing the sign. So you can think about the absolute value as a distance in terms of how far away you are from 0 on a number line. The more mathematical way of defining an absolute value of x looks at, well, how can we define this for any number instead of having to know what the sign of it is right away? So here, if we go back to the absolute value of 3, and in this case x is 3, if we just say that that's equal to x, or in this case 3, that works because x is 3. So the absolute value of 3 is 3. However, if we look at the absolute value of x, or in this case, for x equals negative 3, if we were just to say this is equal to what we started with, x, we would actually have the wrong sign. We want to have a positive here, so the rule mathematically is we have to change the sign of x if x was a negative number. So we have to change the sign of this so we get that positive 3 coming out. So we actually have to define the absolute value with two equations. One, absolute value of x is x if x is greater or equal to 0, or the absolute value of x is equal to negative x when we have an x value that is negative. So you have to negate the x if x is negative in the first place. Another way we can look at this is thinking about this as a graph of a function. So I'll just use y here, but you could use f of x. If we were to look at y equals the absolute value of x, we could graph that out pretty straightforwardly on a simple grid. Let me scale this. So if I have 1, 2, 3, 4 on my x-axis, and on my y-axis I'll go up the same distance, just to give a start to my graph. Oops, that should be a 3 and this is a 4. If x is 0, then my y value is 0. If x is 1, the absolute value of 1 is 1. If x is 2, the absolute value of x is 2. When x is 3, you get the absolute value of 3 is 3. So you get this nice basic line on this side that's going up with a slope of 1. However, when you start to enter negative numbers over here, so say negative 1, negative 2, negative 3, negative 4, when we take the absolute value of a negative 1, we get a positive 1. Absolute value of negative 2 is a positive 2. Absolute value of negative 3 is a positive 3. Absolute value of negative 4 is a positive 4. We actually get another line going the other direction that creates a V shape for our graph of the absolute value of x. So we get this V-shaped graph where on the left side we have a slope that is negative, and on the right side we have a slope that's positive, and together they make this V-shaped graph, which is our graph for an absolute value function. So here we are in Desmos. I'll show you how to graph the absolute value of x here as well. The way we graph this is we're going to enter in y equals, and then the abbreviation for absolute value in Desmos, and it's also this in many calculators, is ABS. ABS for absolute value. And we're going to put in parentheses whatever our inside of the absolute value is, in this case x. So you see that nice V shape coming right up on the graph. So that's all there is to it. There's your absolute value graph coming up as the V shape.